Okay, let's be real for a second. When you see a math problem with a bunch of big numbers, does your brain kind of freeze up? You're not alone. That feeling of frustration, we've all been there. But what if I told you there's a much, much better way to think about math? It's this story we tell ourselves, right? That you're either a math person or you're not. And once you start believing you're bad at math, it's a really tough idea to shake. But is it actually true? Or is something else going on? So here's a thought. What if the problem isn't you at all? What if it's the method you are taught? A method that often focuses on getting the answer fast, but not necessarily on understanding why it's the right answer. Well, today we're going to change that. All right, team, it's time to dive in. For our first section, I need you to put on your detective hats. We've got a math mystery on our hands, and it's our job to find the clues and crack the case. Okay, here's the case file. Alex solved 354 plus 178 and got 422. Now, I'm going to tell you right now, that answer is wrong. Your mission, should you choose to accept it, is to figure out why. Look closely. What did Alex do wrong here? So, did you spot it? Here are the clues. In the ones column, 4 plus 8 is 12. Fine. But look at the tens column. He added 5 plus 7 and got 12. But that's not a 5 and a 7, is it? It's really 50 and 70, which is 120. Alex just treated them like single digits. He completely forgot to regroup, or what we all learned as carrying the one. And that single mistake is the key to this whole thing. To make sure we never make an error like Alex's again, we need a secret weapon. And that weapon is truly understanding place value. It's time to stop seeing numbers as just a bunch of digits in a row and start seeing what's really going on inside of them. The first step is to just unpack the number. Take a look at this example. 2,846. It's not just a 2, an 8, a 4, and a 6 sitting next to each other. It's really 2,000 plus 800 plus 40 plus 6. Seeing a number in its true parts like this, that is the first step to becoming a place value master. Now, this little trick of pulling a number apart actually has a name. It's called expanded form. It's just a fancy way of saying we're writing the number as a sum of its parts. So 356 becomes 300 plus 50 plus 6. Getting this down is the foundation for everything else we're going to do. I love this analogy. Think of a number like a tightly packed suitcase. You can't really do anything with what's inside until you open it up and unpack everything. Your stacks of hundreds, your stacks of tens, and your stacks of ones. Once they're all laid out, then you can start working with them. Okay, so now that we know how to unpack our suitcase, we can finally figure out what's really going on with those old ideas of carrying and borrowing. In fact, you know what? Let's just ditch those words. They're confusing. Let's call it what it really is: trading. This makes so much more sense. When you carry the one, what you're really doing is trading up. You've got, say, 12 ones, which is too many for one column. So you trade 10 of those ones for 1 10. And when you borrow, you're just trading down. You don't have enough ones, so you trade one of your tens to get 10 ones in return. See? It's always a fair trade. Think about it like money. It makes perfect sense. Let's say you need to pay someone 8 cents, but you only have 5 pennies in your hand. What do? You can't just ignore it. You go to your pocket, you grab a dime, and you trade it for 10 pennies. Now, all of a sudden, you have 15 pennies. Paying 8 is easy. That's all subtraction is. Okay, let's put it into practice with 725 minus 348. First, we unpack it. 700 plus 20 plus 5. Right away, we can't take 8 from 5, so we trade. We take a 10 from the 20, leaving 10, and get 10 ones. Now we have 15 ones. Perfect. Next, we need to subtract 40 from 10. Can't do that either, so we trade again. We take 100 from the 700 and trade it for 10 tens. Now we have 11 tens, or 110. From here, it's easy. We just subtract each part. It's just a series of simple, fair trades. So, unpacking and trading are awesome for addition and subtraction. But what about multiplication? Well, for that, we have this absolutely brilliant visual tool that makes everything click. It's called the area model. The absolute best way to think about this is to imagine you're tiling a floor. Trying to calculate the area of the whole room all at once, that's kind of overwhelming. But what if you break that big floor into 4 smaller, more manageable rectangles? You could find the area of each small part easily and then just add them all up at the end. That's exactly how the area model works. And this is what it looks like in action. On the left, you have the abstract problem, 32 times 45. But on the right, You have a clear visual blueprint. The big, tricky problem is broken down into 4 smaller, way easier multiplication problems. Once you solve those, you just add them up. It turns a scary calculation into a simple roadmap. So here's the simple 3-step recipe. Step 1. You unpack both numbers into expanded form. So 32 is 30 and 2, 45 is 40 and 5. Step 2. You multiply the parts to find the area of those 4 smaller boxes. We call those the partial products. And finally, step 3, just add those 4 products together. And boom, you have your final answer. Okay, so we've learned these new strategies, right? But are they really better? Let's prove it. We're going back to our detective work to analyze one more common mistake. And this is where you'll really see why thinking in place value is such a game changer. All right, meet Sam. He's tackling 347 plus 285. And you can see he started off on the right foot. He unpacked the numbers. But something went wrong when he tried to put all the pieces back together. So take a second, put your detective hat back on. Use those new place value skills we've been working on. Can you spot the flaw in his logic? Where did his calculation go off the rails? Here's the diagnosis. Sam did the first part right. 7 plus 5 is 12, 40 plus 80 is 120. Great. But then he just kind of dropped them into columns. He treated each calculation like it was on its own little island, totally ignoring how they're all supposed to interact. That 120 has 100 in it. That 12 has a 10 in it. He forgot to regroup. It's the same mistake Alex made, just in a different format. And this, right here, this is the whole point of today. When you truly understand place value, these kinds of mistakes become almost impossible to make. You stop seeing separate columns of digits, and you start seeing the whole number for what it's really worth. And that changes everything. Now, let's be fair. Is the old way of just stacking numbers faster? Sometimes, yeah. The source material even points out it's more efficient because you write less. But it's a trade-off. What you gain in pure speed, you risk losing in actual understanding. This method of breaking numbers down, it builds a much deeper, stronger, and more flexible foundation in your mind. Which leaves us with one last question to chew on. When it comes to learning, not just math, but anything, what's really more important? Getting the answer as fast as you can, or truly deeply understanding why that answer is right in the first place? Definitely something to think about. Thanks for being a math detective with me today.